Alright, let's look at the homework 13, problem number 1. Alright, so we're going to use the power series method to find the solution of this differential equation. Alright, so let's do that. Alright, so let's plug in the power series here. So we have a 2x minus 1. Then you have a summation. N goes from 1 to infinity of n Cn x to the n minus 1 plus 2 times summation n goes from 0 to infinity Cn x to the n. We want this to be 0. Alright, so let's distribute 2x to this and that. So you're going to get summation n goes from 1 to infinity, right? So 2x, so you have a 2n Cn x to the n, right? And then you have a negative, so minus summation n goes from 1 to infinity n Cn x to the n minus 1 plus summation n goes from 0 to infinity 2Cn x to the n equals 0. Alright, so what we need to do is we want everyone to have x to the n. So this is x to the n plus minus 1, unfortunately. So we want to change that by, instead of starting from 1, we can start from 0. So since we decrease the starting number, we have to increase these indices. So this is going to be n plus 1 times Cn plus 1, and then you have x to the n. Right, so we have x to the n now. Right, this one, it already have x to the n. So I want to start from 0, so I'm going to actually change that to 0. Right, this would not affect this series because when n equals 0, the term is 0 anyway, so you're basically adding 0 by starting from 0, right? So everyone start from 0 and go to infinity, and everyone seems to have x to the n, x to the n, x to the n, right? So we can put them in one big summation, and goes from 0 to infinity, right? So we're gonna put these guys together. So this guy right here and that guy together, we're going to get 2n plus 2 Cn, right? Then you have a minus n plus 1 Cn plus 1, right? Then everyone has x to the n, so I factor that out. Alright, so then we can set the, the right hand side is 0, so we have to make sure that all these guys 0. So we're going to set this guy equal to 0. We get this recursive formula. So I'm going to solve for Cn plus 1. Cn plus 1 is equal to, alright, so you have a 2n plus 2 over n plus 1 Cn, right? But which is going to be equal to, right? Because 2n plus 2 is same thing as 2 times n plus 1. So we can cancel n on the bottom and n on top. So you simply get the 2 times Cn. All right. So we can you know, find a pattern from here. So let's try n equals 0. So we have a C1 is equal to 2 times C0. So n equals 1. So C2 is equal to 2 times C1. But the C1 itself is 2C0. So this is going to be 2 squared C0. Right? And n equals 2. You have C3 is equal to 2 times C2, but the C2 itself is 2 squared C0, so it's going to be 2 cubed C0, right? Then you see the pattern here, right? Cn is going to be, if it's 3, 2 cubed. If it's 2, 2 squared. If it's 1, it's 2, right? So it's going to be 2 to the n C0, all right? So which means that the solution that we are looking for is y equals, right, summation n goes from 0 to infinity. Cn now looks like this: 2 to the n C0 x to the n. Right, pull out the C0, that's just a constant, and combine 2 to the n x to the n. We have summation n goes from 0 to infinity of 2x to the n, right? And remember that we have this series. If you have n goes from 0 to infinity and x to the n, this is 1 over 1 minus x if it converges. All right, so here we can write this guy as C0 times 1 over 1 minus 2x. All right, so we should probably write it as, just put C0 up here, right? You have that, right? So that's it. Oh, actually, then my answer should have C0 in there. So should have C0 there. All right, that's it. I hope that this was clear.